This is section 7.2, problem number 4. Over the past several months, an adult patient has been treated for tetany. This condition is associated with an average total calcium level below 6 milligrams per deciliter. Recently, the patient's total calcium test gave the following readings. All right, so we've got what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 readings. All right, so n is equal to 10 here. Part A. Use a calculator with a mean and sample standard deviation to compute X bar and S. And then in Part B, all right, find a 99.9% confidence interval. Let's put this data into list 1. So here's what we're going to do. We're going to go to Stat. So press the Stat key. Select number 1, which comes up right away, which is Edit. Because we're going to edit, we're going to put numbers in. So you select number 1. Now, what comes up is list 1, list 2, list 3. There's 3 others that we can't see. But we may have data already in list 1 from a previous problem. So you need to clear that. All right, so get your cursor over in list 1. Your cursor's in list 1. Use the up arrow, get the cursor right on L1, and then press enter. Or clear. All right, so get your cursor in list 1. Move the cursor, use the up arrow to get it to actually on L1. Press clear, and then enter. And that should clear all that data from that list. So let me clear that out too. Now just start typing your numbers right in there. So it's going to be 9.1. You can put the 0 in if you like. 9. 10.3, ... You just put all those numbers into the last one, 12.10, 12.1. And when you get them all in, down at the bottom, it should say L1, and then parentheses, it should say 11. That means it's expecting number 11, which means that you have 10 pieces of data in there. Now we have to do some calculations. So here's what you're going to do. I've already got it up here. You're going to go back to Stat. So press the Stat key and over to Calc. We're ready to do some calculations. So Stat Calc, select number 1, one variable stats. And when you select number 1, what comes up is list, frequency list, and calculate. All right, list. All of our data is in list 1. So you want to get list 1 here. You want that to be L1. So how do you get L1? You press second, the numerical key 1, because right above the 1 is the L1. So press second, numerical key 1, and list 1 comes up. Now once you've got L1, you go down to frequency list, and you want this to be blank. Right, so I think if you press the delete key, it will blank that out if it's not blank already. Mine's got a flashing A for alpha character, but I think you want it blank. So just put in a delete key right near the top, just 2 over from the second key, and then press the down arrow. That should get you to Calc, and then press enter. Right, so you go down to Calc, you press enter. Now here's what my calculator shows. At the top it shows X bar equals 9.97, and then down a few lines it says S sub X, the standard deviation of the X's, is 1.0198, and so on. Of course, they're asking us to round off, so let's look over here, and it says to round to 4 decimal places. All right, so X bar is only to 2 anyway, so I'm going to write this as 9.97, and S, I am going to round to 4. 1, 2, 3, 4. Now that's a 5. Statistical rounding, I round to an even number, so I'm going to leave that as an 8. So 1.0198. 1.0198. Part B says find a 99% confidence interval. Okay, so now what we're going to have to do is we're going to have to go back to Stat. Now over to Tests. All right, so here's where we're going here. We are going to Stat, Tests. Now once you get to Test, the first 6, 1 through 6, these actually have to do with hypothesis tests. That's not what we want. We want to go down here to 7, 8. Now we need to decide what we're going to use here. 7 is a Z interval. 8, let me get down there, that is a T interval. So we're going to use Z or T. Well, look what we have. We have a sample of only size 10, and anywhere as I read this, I don't see that we're given a standard deviation. So we have an unknown standard deviation and a small sample. So I think what we're going to have to do here is we're going to use the T distribution. All right, so select number 8. So you select number 8. When you select 8, here's what comes up. What do we want, data or stats? Well, we want data, right, because we put all of our data into list 1. We have individual pieces of data. We put that into list 1. So you're going to select data. Get your cursor over on the data and press enter. Now, down arrow to list. All right, so you want your list. Now, what do we want here? We want list 1. Now, you know how to get list 1, right? What are you going to do? You're going to press second and then the numerical key 1. All right, so you get list 1 here. Now, frequency, all right, so down arrow. Frequency, we actually want that to be a 1. Every one of those data values we put it in once. So frequency should be 1. And now the confidence level. The confidence level that they're asking us for, 99.9. So you can just put in 99.9 and then go down to calc. So it took a while to get it because it's a T distribution, so it's a little bit more involved than the Z. So here's what I'm getting. I'm getting 8.4281 and then a comma and then 11.512. That's my confidence interval. And what does it want? It wants a lower limit rounded to, right, I'm up here. It wants round to 2 decimal places. All right, so if I round this, I'm down here now, my confidence interval, round it to 2 places, 4.2, that's an 8. I'm going to round up, so I'm going to write 8.43, if I can get it to do this, 8.43, and my upper limit, the upper limit, round to 2 decimal places, 1, 2, I'll just drop this, so I'll get 11.51, 11.51. Now, Part C says, based on your results of Part B, based on our confidence interval, we're 99.9% sure we've captured this patient's true calcium level. So we think this interval here captures it. And the problem results when it's below 6. So where are we here? Here's 6. We're over here in this interval right here, right? 8.43 to 11.51. So the question is, what is the question? Do you think the patient still has a calcium deficiency? I'm going to say no, because that's outside. Our interval is higher. So we think that the true mean is probably in here somewhere. So let's say no, we can get rid of these. No, this confidence interval suggests the patient may still. No, this confidence interval suggests that the patient no longer has a calcium deficiency. Let's go with that one right there.